Yes.
Okay,
Yes.
okay, that's fine. So it's just the introduction. The first thing that we're going to do is sort of like a recap of your from of things from I think from primary, right? So we're going to look at the common plane shapes that you once did, uh, either back in primary or form one, form two. I'm not sure, right? So we're going to start with the rectangle, right? So a rectangle, the dimensions of a rectangle. Remember, we have the length and then we have the width, right? So the perimeter of a rectangle, you know that it's length plus width plus width. So it's just 2 length plus width, right? 2 times length plus 2 times width, okay? And then for area, we know that area of a rectangle is equal to length times width, right? So I'm not going to spend much time on these ones. And then for a triangle, right? If we have a triangle like this, right? Then this is the height. And then let's say this is side A, this is side B, this is side C, right? So we know that the area of a rectangle, of a triangle, sorry, is equal to half base times the height if we're given the base and the height. So if you're not given the height and you're given, let's say, this angle theta, right? So it becomes half AB sine theta. So it's half times A times B times sine theta. The angle that is between these two sides, side A and side B, that is what gives us the area, right? So and then for a trapezium, you know that for a trapezium, so a trapezium is like this here, where we have these parallel sides. These are parallel sides. So this is A, and then you can call this B, and then this one will be our height. So we have A, this parallel sides B, and then the height. So the area of trapezium is equal to half A plus B times the height. That's what gives us the area of a trapezium. And then for a square, right? For a square, we know that a square is like this. So it is this side and then this side. So the area of a square, we know that area of a square is equal to side times side. And then for perimeter is equal to 4s. So that's the perimeter of a square. And then the area of a square. And then for a circle, right? If we have a circle like that with the radius r, remember if this is the center and then we have radius r, so the perimeter, so it's called a perimeter, or we can say the circumference. We can say the perimeter of circumference is equal to 4, sorry, is equal to 2 pi r. So it's equal to 2 pi r. And then the area of a circle, area is equal to pi r squared. So this is just a revision from the previous years. I hope you have encountered it, right? So you have to know the different formulas to apply in those shapes, right? So our main objective today, we want to cover. So today we want to cover mostly arcs and sectors of circles, right? So we want to do arcs and sectors of circles. Okay. So what do you mean by an arc, right? So suppose you have your circle here, right? So we have a nice circle like that, and then a piece, right? If you cut, let me just change the color here, right? If you take a piece, right? Let's say it's a cake. If you cut a piece, and then the angle here of this piece, let to the center is theta, right? And then let's say this is point A, and then this is point B, right? And then this is our radius, right? So if you want to find the length of this arc here that I'm marking in purple, right? The length, it's called an arc AB, right? So length of arc AB is equal to, so it's given by theta over 360 times 2 pi r, right? So it's theta over 360 times 2 pi r. That's the formula that gives us the length of this arc AB, right? So example, let's look at example 1, right? So it says an arc, right? An arc, let me remove this. An arc subtends an angle of 105 degrees at the center, of a circle of radius 6 centimeters. Find the length of the arc, right? So we want to find the length of the arc, right? That subtends an angle of 105 at the center of a circle of radius 6 centimeters, right? So to visualize what's happening here, it is a circle. We have a circle here, right? And then we're seeing an arc like that one. So if this is the center, right? So it is a radius of r, and then subtends an angle of 105 here. So 105 here at the center. So we want to find the length of this arc, right? So we just say we just give this point A, and then we say this point is B. So we want to find the length of this arc. So we know that length of arc is equal to theta over 360 times 2 pi r, right? So it depends on the value of pi that you've been told to use, right? So pi is 22 over 7. Usually it's 22 over 7. You're told that pi is equal to 22 over 7. It's a constant. So which means with theta is 105 over 360 times 2 times our pi, we say it is 22 over 7. So we have times 22 over 7 times the radius. We've been told that the radius is 6. So we say times 6, right? Which gives us, then on the calculator, go 105 times 2 times 22 over 7 times 6. So we get, we're going to get, if we round off, so we're going to get roughly 11 centimeters. So we're going to get 11 centimeters. That will be the length of this arc AB. Are you following, guys? Please say something.
Yes.
Okay.
Yes.
Okay, that's fine. So let's look at example 2, right? Example 2. Want says calculate the perimeter. Calculate the perimeter of a sector of circle of radius circle of radius 7 centimeters, radius 7 centimeters, right? The angle of the sector, being 108 degrees. Is there anyone who wants to try? Anyone?
I want to try.
Okay, so let me just draw it for you. So we have this sector, right? So the angle is 108 here, and then the radius, right? So the radius is 7 here, and then we have 7 here. So that's our sector like that. Okay, so how do you find the perimeter?
Of the sector. So since we said I think we're going to say 108 over 360
Uh,
times 22 over 7
uh,
times 2.
uh,
Yeah. Times 7.
times 7, yes. Okay. So this is finding the length of the arc. What do we get? If we work that one out, what do we get?
We get 13.2.
Okay. Uh, and then what do we do now? You've not finished, Ruimbo.
We square it
Square it. Why? So
because
we want the
it's
perimeter.
now
Huh? Remember, we want the perimeter. So which means we're going to find the length of the arc here, right? Which I'm demarcating in purple. And then, so if you get the length of this arc, then we add this R and then this R. Do you see that? Because we want the perimeter.
okay.
So we're going to say 13.2 plus 7 plus 7. So what do we get now? What is the perimeter?
27.2.
Okay, 27.2. Okay, thank you, Ruben. Okay, so that's on length of or length of an arc. So now I want to look at how we find the area of sector. Right? Area of sector. Right. So we have the same circle. If we have a circle like that, and then we have if we take out a sector here like that, so this is the O, the center, and then the angle is theta here, and then from A to B like that, right? So if you want to find the area, like let's say we cut a piece of cake, right, from a whole cake. If you want to find the area of this cake or the sector, right? So area is given by, we say theta over 360 times pi r squared. So this is the area of a sector is equal to theta over 360 times pi r squared, right? Example 1. It's example 3, right? Sorry. Example 3, right? Calculate the area of a sector which subtends, right, an angle. Calculate the area of a sector which subtends an angle of 80 degrees at the center, at the center of a circle of radius 12 centimeters. Is there anyone who wants to try? Any volunteer?
I want to try.
Okay, ma'am. Can you please help us?
So you're going to say 80 over 360
Okay, so the area is equal to 80 over 360.
multiplied by 22 over 7.
Uh,
Um, multiplied by 144. Because we squared 12 centimeters.
okay, so it's 12 squared. Okay. Okay, so what do you get? Simple and straightforward. What do you get?
Um,
Eighty over 360 times 22 over 7 times 12 squared.
mm,
So you say
mm,
80 divided by 360, and then you get your answer. Then you say times bracket 22 divided by 7. That's how you punch it, right? And then you say equal to, then you say times 144.
okay.
Yes. So what do you get?
It's showing
So it's 80 divided by 360 equal to, then
300.
you say times.
100.5.
Okay, thank you. So it's 100.5, right? Okay,
Yes.
so it's 100. So okay, just to the nearest whole number, so it becomes 100 square centimeters, right? Okay, so let me just project a few questions. Then we'll hear from others who haven't said anything, right? Okay, so confirm you can see the question. Those two questions there.
Yes.
Okay, so who
Yes.
wants to try? Do we have volunteers? Hello, guys.
I want to try.
Okay, please, Ruimbo.
So area of a sector, we're going to say 60 degrees
Uh,
over 360
over 360
times 22/7
times 22/7, yes.
squared. So times another 20/7.
Pi r squared. I said pi r squared, right? So it's times 7.5
Oh,
squared.
times 7.5.
Yes. So what do you get? So we have 60 divided by 360, okay, times 22/7, right, times 7.5 times 7.5. You got 29.4. Is that so?
Yes.
Okay, 29.43. So if you just round it off to two significant figures, so which means we have 29. So we get 29 square centimeters. Okay, thank you, Rainbow. And then the other question, who wants to try?
Yeah, I can try.
Yes, please, Bradley.
Right. So area is theta. So our theta is 45
Okay, 45
over 360
over 360
times 22/7.
So, Bradley, you see the question,
Yeah.
right? It says in terms of pi. So we are not simplifying
Oh,
pi
also times pi.
times 8, right? It's 8, right?
Yeah.
Times 8 squared times pi. Okay. So how do we simplify now? What do you get? Right? So 45 divided by 45 over 360. So this is 1/8 if we are simplifying, right? Times 8 squared, it's 64, right? Pi. Yeah.